Hello everyone and welcome back to your own channel, and today we are going to discuss about derivative of function fx or y. Well, talking about mathematically, it's just definition given to the derivative of function fx is instantaneous change in rate of instantaneous rate in change of function fx with respect to the independent variable x. That means if x moves very instantaneously, then the change occurred in fx. When you divide both of them, you will get the derivative of the function fx within that change. Now, just concentrate on this word instantaneous. That means it's in very instant that nobody can see. Nobody can tell a change. It's that instantaneous. So, like, let's fx be a function of position of an object with respect to the time t. So here t is an independent variable and fx is dependent, that depends the position of o. Position of the o depends on fx, which depends on an independent variable t. Now let us assume that there is a time period a where the object is at position p, and in some h second the object reaches the point q. So in a plus h time period, it is at q, while at a it is at p. So it cover the position has a difference of pq in some h seconds. Now we have to find derivative at p. So as derivative counts for the instantaneous rate of change, so what we can do is we can minimize this distance pq almost equal to 0. That means pq approaches 0. pq is so small that it approaches 0, that p and q can be found coincident. So that's the catch here. So h second is very small and this approaches 0, very small. So with this example we can come to a conclusion. Derivative of fx with respect to x is change in fx and change in x, and remember this change is very instantaneous, so this is almost approaching to 0, which for any point a it can be like limit h approaches 0 f of a plus h, the point where it will be when h change occurs in x, and f of a, the point where it was initially upon h the change occurred. And h approaches 0, that means this change is very small, that those 2 points can be found to be coincident. So generalizing it to the case of whole function, the derivative of a function can be given by derivative of f of x upon derivative of x. Derivative of f of x with respect to x is f of x plus h minus f of x upon h. Okay, so and h approaches 0, that means it's very small change. Now let's just take this example, and how about we find the derivative of a very interesting function sin x, a very common trigonometric function. Invoking this formula, derivative of sin x with respect to x is limit as h approaches 0 upon sine of x plus h minus sine of x upon h. Now note that we have to solve this limit to find the derivative of sin x. Now look at this very carefully. If h approaches 0, this function, this value is approaching to 0. Okay, and as h approaches 0, this value is approaching to sin x, and this value is already sin x minus sin x, so this value as a whole is approaching to 0. So this is an indeterminate form because it's in 0 by 0 form. So we have to make some changes here so that we could solve this indeterminate form. Now to understand those changes, I want you to understand very particular thing. It's sin x limit as x approaches 0 for sin x upon x is nothing but 1. Now why is it so? We can There is this known as sandwich theorem. Sandwich theorem states that if f of x is less than equal to g of x, which is less than equal to uh, some k of x. Sandwich theorem works like that. If this is true and this equal to holds for some value, now how about if limit of some particular a of f of x is actually some L, and limit of some x approaches some a for f of x is actually L, then we can say that limit of x approaches a for g of x, this is actually k of x, sorry, is L. This is known as sandwich theorem. Now why this holds true? It could have a peculiar uh, whole definition, but let us assume three people: John, Johnny, and Jagannath. Okay, now three of them are gym freak. Now if John eats 1200 calories and Jagannath eats some 1500 calories, then this guy eats between 1200 to 1500 calories. That means this guy intakes the least number of calories, this guy intakes the maximum number of calories. So this guy always intakes the value in between them. Now if that's hold, if both of them intakes equal amount of calorie, then this guy also will intake some the same number of calorie. So that thing is also true for the sandwich theorem, and it works like this. If you go for the graphical explanation, you will find them coinciding that point where limit becomes equal. With this example, you could actually find proof to this theorem. Limit x approaches 0, sin x upon x is equal to 1. The proof is very simple. As you know, sin x will be always less than x, less than equal to x. This equal to holds true when the angles become really small. So sin x will be always be equal to x. Okay, so what x is big? That means sin x upon x will always be less than equal to less than x. Why is this true? Because it is divided by x, and sin x is already x. So if you divide a small number, and we know sin x is less than x, small number with a big number, it is already small, and the small number is already smaller than x, so this whole will be smaller than this, and this sin x upon x will be greater than sin x. Why is that so? Can you tell me why is that so? Well, I don't even know why is that so, because that's not so. Sin x upon x won't be, sin x upon x will be the smallest here, sorry I don't have a degree yet, will be less than sin x and will be less than x. Okay, let me think about it. Is that even really hold true? Sin x is an angle which is divided by someone larger than this, it of course goes one. Like if we take example of 3 by 2 is less than 3, there is no wonder in that. Okay, and 3 by 2 is of course less than 3 by 4 is of course less than 3. Okay, so yeah, this holds true. So as we know that value of sin x will be equal to 6. Oh my god, that was cool. Yeah, so as you know, sin x takes the value in between x and sin x upon x. So by sandwich theorem, as we know, limit as x approaches 0 for x is 0. Okay, and for sin x, limit as x approaches 0 is 0, as clear. So if the middle term becomes 0 and this becomes 0, this would of course, this one will reach 0 and this will reach 0, so this will actually become 1, and there was no point in telling about all that, and I'm a fool. Well, I may be fool and all, but understand this next thing. So we came to this conclusion that limit of sin x upon x, wherever it is, yeah, this one, we came to this conclusion, and with some peculiar understanding, and if you invoke your own brain, you will came to that point, and I don't know where I'm going wrong. I should look it through my examples once again. So if we come up with that conclusion and we apply this over here, sine of x plus h, sine ho gaya wo, I mean, okay, I'm not an Indian, upon sine of, Indians are really smart in maths, I am not, upon h. Okay, now invoke an identity over here. The identity is sin a minus sin b. The identity is sin a minus sin b says 2 cos a plus b by 2, 2 cos a plus b by 2. That means x plus h by 2 into sine a minus b by 2, which would be h by 2. Okay, so this identity is invoked upon h. Now let this 2 come in denominator, and this would be h by 2, and this one term would be sin h by 2, and here would be a separate term cos x plus h by 2. Okay, and we know the limit as h approaches 0. If h is approaching 0, h by 2 is approaching 0, and sin h by 2 is approaching 0, so this will come upon sin x upon x as x approaches 0, and this will turn into 1, and this is actually not plus, this is into, yeah, this is into, so this all turned into 1, and this doesn't have any 0 form, so this is not an indeterminate form, and we can just simply find the answer as h approaches 0, h by 2 approaches 0, and x, so cos x, it remains cos x. So here we got derivative of sin x with respect to dx is cos x, and I messed a lot, therefore sorry, but 12 minutes video, worth it.